What's up guys, and welcome back to the channel. The question we're going to be going through now is crucial because according to the examiner's report in 2023, a high proportion of students didn't even attempt it. And these questions are worth 5% of the paper, which may seem small, but that's the difference between an A and an A star, which is the difference between going to a Russell Group university and not going to one. Essentially, all they want us to do is to sketch a complex number graph according to two requirements. Focus on the argument bit first, that is, this condition here. Since by focusing on this, it acts as a lever for the other condition over here, making this whole question much easier. All this says is that we must first plot a point at 0i on the imaginary axis and then -1 on the real axis, as we have rearranged the equation like this. Quick note, this was done because in order to even plot a point on an Argand diagram, you need it in the form z minus. Now from here, extend a line from this point such that it makes an angle of pi/4 at a maximum and 0 at a minimum. Now, everything in this area meets the required condition. Next, we plot the points of both 0 plus 2i and -2 plus I. After this, we're going to draw a line in the other direction to become the perpendicular bisector. We draw the perpendicular bisector because when it comes to these types of complex number inequalities, this is how the condition is represented graphically. In order to plot the perpendicular bisector accurately, first work out the gradient between 0 plus 2i and -2 plus I, which is 1/2. Once we have this, we can find the gradient of the perpendicular bisector by flipping the fraction and multiplying by -1. This gives us -2. From here, we're able to find the equation of the bisector quite easily. It's just a case of plugging it into the following formula, which gives us y is equal to -2x minus 1/2. Now, pay attention, because this is a bit where you can easily slip up. What this inequality is saying is that the distance of z from -2 plus I is greater than or equal to the distance of z from 0 plus 2i. This means that the inequality describes the points that are closer to 0 plus 2i than they are to -2 plus I. Combining both inequalities then gives us the following. As you can see, it's this little gap combined with what we had before. And that's it. A hard question done and 4 marks gained. to be a perpendicular bisector. We draw the perpendicular bisector because when it comes to these specific types of complex number inequalities, this is how the condition is represented graphically. Now, the condition says that 0 plus 2i must be smaller than or equal to negative 2 plus I. So therefore, the only region that is valid here is this bit on the y-axis. And so, therefore, since we have our perpendicular bisector 2, we will be in this region only, combined with all of this on the right. And there you have it. 4 marks sorted, a difficult question completed, and that's about it.